Hi everyone, in this video I'm going to be going over synaptic plasticity. Okay, so first of all, what is synaptic plasticity? Synaptic plasticity is defined as the ability of neurons to remodel themselves. So we'll get into what this means a little bit later in the video, right? So first, let's think about something. Your neurons, before you know something, like, okay, before this video, I'm assuming that you know absolutely nothing about synaptic plasticity. So your neurons, I'm sorry. Okay. So your neurons are wired in a way where they don't know anything, right? They just think that you still don't know anything. But what happens when I learn the information? If the neurons are still wired in the way that I don't know anything, then you're not learning anything, right? So how do you learn? So learning occurs through synaptic plasticity. Your neurons will change the way they connect with each other so that you will remember the information, so that the information will occur and will be retrieved in different ways, right? So, in order to create long term memory or in order to learn, your synapses or the way that your neurons connect need to constantly change themselves. They need to remodel themselves so that you can learn. And this has been mainly studied in the sea slug, also known as Aplysia californica. This is a really common trivia question in Brain Bee, so I suggest you remember the name sea slug or Ellipsia californica. Okay, so basically, synaptic plasticity contains two main processes. I'm going to circle LTP in green, which is known as long-term potentiation, and this increases the effectiveness of your synapse, which means it makes it better, right? So me personally, how I remember it is that when you learn something, you become smarter, thus you become better. So LTP, which is potentiation, it gives you potential to be better. LTP increases the effectiveness of the synapse. Then you have a opposite um, action of LTD, right? So your LTD is called long-term depression, and it decreases the effectiveness of the synapse, right? So it decreases it. What this means is that so basically depression, it makes you dumber. And I think when you're dumber, you feel sad, right? So that's long-term depression. And what it does is it reduces the effectiveness of the synapse. So this is why people say when you don't practice a skill for long enough, you tend to forget it because your brain thinks that, oh, they're not using the skill anymore, so they don't need it. So I can reuse the resources for something else. So it kills the synapse. So we'll get more into this in the next slide. So LTP and LTD are actually two very similar processes. Um, let's first start off with the process of neurotransmission. I think you guys remember this, right? Your postsynaptic neuron receives a neurotransmitter from your presynaptic neuron. So your presynaptic neuron is the neuron that's sending the signal to the next one. And it receives a neurotransmitter, it binds, and that chemical reaction is converted into an electrical reaction, yada, 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 right? So let's start from that point. First, the step one is that your neuron receives a signal. So, and then the common reaction for this, it happens in both LTP and LTT, is that Ca ions and sodium ions. One second, I just need to check the charge. Oh, that's not right. Na plus, I believe. Yeah, plus. Okay, I'm smart, guys. Um, ions rush into the cell, right? Rush in. So what this means is that whenever you receive a signal, a neurotransmitter binds, right? Neurotransmitter. Whenever the neurotransmitter binds to the receptor, calcium ions and sodium ions rush into the cell to create to elevate the membrane potential to start an action potential, right? So here's where LTP and LTD start to differentiate. In the process of LTP, what happens is that the concentration of calcium ions is increased to a drastic level, right? It's like super drastic, okay? Whereas in LTD, this calcium 2 plus or the calcium ions are increased, but they're a small increase. So I just draw a tiny arrow. So it's a tiny arrow. What happens now, LTD, we'll come back to that. But for now, let's focus on LTP. Calcium 2 plus, or the calcium ions, are what's known as a secondary messenger, right? So, secondary messenger, meaning it can initiate multiple reactions in the cell. So let me explain, right? So due to the influx of calcium ions in the cell, what the neurons will do is they'll detect it, right? They'll detect the increase. It'll detect increase, detects increase, and the increase will activate CM, right? Which is cyclic adenosine monophosphate, I believe. Um, which is also a secondary messenger. If you've been over cell signaling and transduction pathways in AP Bio, this may sound familiar to you. But for the people who haven't, here, let me just explain it to you in very simple terms, right? I'm obviously going to dumb this down a little bit. And it's not 100% like to the point accurate, but it's pretty accurate. So CAMP, what it'll do is it'll cause a bunch of reactions, right? It'll activate one protein, another protein, and another protein. So basically, CAMP will activate this protein. This protein will also activate the protein that's activated will activate another protein, and then another protein, which basically the whole point of this is to amplify a signal, right? Amplify a signal. You don't need to know this. It's just easier to get an understanding of what's going on, right? So that your cell can hear it. Oh my gosh, this is so irritating. I'm sorry, guys. Okay, sorry, I wasn't talking about the video. There's a pop-up that keeps coming up. Anyways, um, finally, this protein will activate something called CREB, which is C on receptor element binding protein or something like that. Basically, what it does is it activates, it goes into the nucleus of the cell, right? Say this is your nucleus of the cell, and it will make genetic modifications. Genetic modifications. It'll make genetic modifications to the cell, which activates protein synthesis. Protein synthesis, which is basically the creation of new proteins, right? It creates new proteins. And what this protein will do is it can do one of two things. I'll just come over to the side here. It can, one, increase the sensitivity by either increasing the number of receptors or making it, I think it's creating new connections or by like releasing more neurotransmitter. Releasing more neurotransmitter. Let me just double check. Okay, so I double checked and actually I was a little bit wrong in the way that I explained it. So let me just clarify. Um, your crab does not increase the amount of neurotransmitter release, but what it does do is it increases the sensitivity of it. So even just a little bit of a contact will cause a very drastic reaction, right? So basically it increases sensitivity. And what it will also do is in addition to increasing receptors, it'll also release growth factors to increase the stability of the synapse. Okay, so let's take a visit back to LTD. So basically, these proteins that are consistently activated are what are known as kinases, which are a group of enzymes, right? Enzymes are proteins which keep activating or phosphorylating each other, which is adding a phosphate group to activate them each time. So what happens in the case of LTD is that, and okay, and the way it stops is through an enzyme called a phosphatase, right? So I'll write that over here, where I'll use different color, I use red, called phosphatase. Taste. Okay, so what phosphatase does is it removes the phosphate group once and for all. So these proteins can't keep activating each other. What happens in the case of LTD is that once the calcium ion comes in, phosphatase comes in directly and just stops the phosphorylation, stops. It's just done. That's it. You can't move forward from this point. And the reason this happens is because your neuron, so what happens as a result of this is that you no longer release this growth factor, right? So your neuron doesn't grow anymore and it doesn't have a reason to keep growing. So what happens is ultimately this synapse just dies off. That's it. It's just gone. So that's why kids, you need to practice something and you need to learn and you need to keep reinforcing what you learn. Um, so yeah, I hope this was a helpful explanation of LTP and LTD. You need to really understand that LTP is the process in which your brain creates long-term memories, and it's a process that enhances your ability to learn, whereas LTD is the process in which your brain loses its synapse. Now, you may be wondering, why would your brain create LTD? Isn't that bad? And or you also may be wondering, why not create a wonder drug which basically enhances LTP and completely suppresses LTD? So everything in your brain is a balance, right? So in this case, if you let's assume that you want to keep remembering everything, but you don't want to forget anything, what would happen is that your brain is putting so much energy into those unnecessary synapses. So the things you don't practice, right? The things that you don't really use in your day-to-day life, what we don't realize is that by not using those take up energy to maintain no matter what, right? Even if you're using them just a little bit and or even if you're just not using them and you just are keeping them in the back of your brain needs to put in energy to maintain it in the first place, which is a waste of energy. Why would you allocate that energy to something that you don't need? It's better to just forget it at that point so that you can learn new things. Your brain has a set capacity of energy, right? It can't go allocating it everywhere it wants to. So it needs to choose and prioritize. Therefore, the person who has arguably the best memory is a person who can remember things and forget things, right? There needs to be a constant balance, the homeostasis, right? So that's why it's so important to forget as it is to learn and practice. So that was the video. If you have any questions, please email me at stemwme@gmail.com or leave a comment. Thank you guys. Bye.